Good day, my friends. I am Marcos Halme, your teacher for today. In this video, we are going to tackle about vectors using trigonometric functions. In order for you to understand this lesson, you first must have prior knowledge about vectors and trigonometry. And this is our objectives.
To understand the fundamental concepts of vectors and how trigonometric functions can be used to analyze and manipulate them effectively. By the end of this presentation, you will be able to apply trigonometric functions to solve vector-related problems confidently.
Here is an example problem. Problem number 1. A soccer ball was kicked 50 meters across the field in a direction that is 50 degrees north of east.
How can you use vector analysis and trigonometric functions to determine the x and y components of the ball's displacement?
So, to solve that problem, we first must have to write down the given. It was said that a soccer ball was kicked 50 meters in a direction that is 50 degrees north of east, and the x and y components. Now that we have all the given, we will now proceed on the next step, which is drawing a visual representation of the problem. In this step, we are going to draw a Cartesian plane and then label each directions. The horizontal line represents the west and east, and then the vertical line represents the north and south. We will then incorporate the problem into our representation. We drew the triangle 50 degrees to the north of east side because of the given. After drawing that, we're going to label each side of the triangle. 50 meters to the side where the ball was kicked. The vertical line is the y component and the horizontal line is the x component. For the next step, we are going to solve for the value of x and y components. We are going to use the trigonometric function, whereas we have a triangle and we can incorporate our given to this triangle. In trigonometric function, we have the so-called SOHCAHTOA, which are the formulas that we are going to use to solve for the values of x and y. SO stands for sine theta is equals to opposite over hypotenuse. Ka means cos theta is equals to adjacent over hypotenuse. And TOA means tan theta is equals to opposite over adjacent. Now, the formulas that we are going to use are only the SO and Ka. And that is because TOA doesn't have a hypotenuse in its formula, so we're not going to use TOA, since the value that we only have is 50 meters from the hypotenuse. Now let's solve for x. Cos theta is equals to adjacent over hypotenuse. Now if we substitute the values, we will have a cos multiplied by 50 degrees is equals to adjacent, which is our x, over hypotenuse, which is our 50 meters. And then we have to derive the equation so that x will be the only one left in the other side. We can do that by multiplying each side of the equation by 50 meters. Because by doing so, we can cancel the 50 meters below the x. And now there you go, we have our final formula, which is x is equals to 50 meters multiplied by cos multiplied by 50 degrees. So, let's use the calculator to calculate our value of x. The value of x has a lot of decimal values, that is why we're gonna round it off to the third decimal value. And so, our final value for x is 32.139. Let us now find the value of y using the same process, but this time we're going to use the SO formula. We will do the same process as we did in the cos formula, starting by substituting the given into the equation and then deriving the equation in order to find the formula for y. Next, after finding the formula for y, we will calculate the final value. And as we did earlier in the x, we will round up the final value of y into the third decimal point. We are not done yet, because after finding the value of x and y, we will now use the Pythagorean theorem in order to check our answers. The formula is c is equals to the square root of a squared plus b squared. C is the same as hypotenuse, A is the same as adjacent, and b is the same as the opposite. So, we will use this formula in order to check if our answers in x and y is correct. To know if it's correct, the hypotenuse should be the same as in our problem 1. We will now substitute our x and y into the adjacent and opposite, or the a and b. So, our final calculation is 49.995 and so on, so we can round it off into 50. And let's check if it's the same. Yes, it is. Therefore, our calculation for the x and y is correct. Now, I want you to solve for problem 2. Our problem 2 is...
Imagine you are an architect. You are tasked with designing a bridge. You will need to create a bridge spanning 125 meters across a river. The bridge must be angled at 30 degrees to the riverbank north of west. How can you use vectors and trigonometric functions to calculate the bridge's horizontal length and the height of the bridge vertically for the bridge's suspension cables to ensure stability and safety?
You can now pause the video to solve. After solving, play the video again in order to see if your answers are correct. Alright, now I'll assume that you're done. Let us now check your answers. First, we'll write the given. Then after writing the given, we will write the visual representation. Kindly check if we did the same process. Now let's use the trigonometric function to solve for the x and y using SOHCAHTOA. Kindly check if our solution is the same. The value of x is 117.462. Now let us solve for the value of y component. So we substitute, derive, and then calculate. So the final value for our y component is 42.753. Let us now check if our answers are correct using the Pythagorean theorem. Now using the calculator, we get the value of hypotenuse, which is 125. Therefore, the value of x and y component that we solved is correct. Now guys, tell me, do we have the same answers? Let me know in the comment section below. This is the end of our lesson. I hope you learned something today. Thank you for watching. Bye bye.